chose to do my bridge in a K-truss design for a couple of reasons. First reason is a very equal amount of tension and compression within the wood, and that's good because you want to have tension and minimal amounts of compression. I also chose it because it's kind of different and unique. The other reason is there's large amounts of beams going across, so it provides a large amount of support for the weight that is put on. Unfortunately, it wasn't the best for the situation that we were given, because there was one situation of weight just pushing down right there. Instead, this is designed for multiple weights being pulled down in multiple points. Also, this bridge kind of looked cool, and that's one of the main other reasons I picked it, and it was unique. I wanted to try something different other than what other people were doing. The reason that you want to have wood tension rather than compression is because wood's tensile strength is more than 5 times the strength of compression. So when you pull on wood like this, it stays together, whereas when you push on it together, it'll come up or bend and then fracture. So that's why when you want to have the multiple amount of tension joints compared to compression joints. For our bridge deck, I went with 2 parallel beams running lengthwise, with cross pieces running this across the opposite direction, perpendicular to the parallel beams. This is for reasons because I wanted it to provide lateral strength for the wood, as well as provide a place for the wood weight to push down onto the bridge. This helped create a sturdier environment and help give the bridge stability to prevent it from twisting and bending like this by providing a strong surface. On my bridge deck, my horizontal beams around it were flat like this, seen here where the bridge beams are not very sticking up. In an ideal situation, I would have done my beams with this, where they're sticking up on their sides, like this, instead of like this, because there's more strength in the beams when they're on their sides rather than laying on their flat. The reasons for this is when you see like here, when you apply a force down on the beams, there's more wood underneath of it, and the grain is greater this way, so the beam doesn't bend as it's pushed down. Whereas when the beam lies flat, when you apply a force to it, the same force, that same beam will bend underneath due to the less thickness and the grain running in a certain direction. This is why you want to have your beams like this on your joints like this. My bridge had 3 main joints. A lap joint, a bridge just this where I stuck on the ends of my triangles for my K-trusses onto the cross beam, and these flat joints where the cross beams were laying across the bridge connecting the 2 sides together. My lap joint was designed so that there was optimal lots of surface area between these 2 woods, as they would be supporting the majority of the weight for my bridge. These joints were glued on and left to sit for a long time, as they were taking the pressure off of these and distributing it throughout my bridge, so there's multiple points where these triangles are connected onto the cross piece all on the bridge. And finally, there were these cross joints here that connected the bridge together. Unfortunately, they lacked surface area to connect from here to here, so it caused warping in my bridge. And so when you look at it, they aren't exactly straight, and my bridge leans to one side on either end. Actually, it's better illustrated on this end, so you can see where they've slipped and they're hanging over the edge, because I had to fix it early in the morning, and so that's part of my problem, and I'll demonstrate how I would have better fixed this in another. One thing to help prevent the warping in my bridge that I added was cross bracing. I added beams alternating from point to point along my bridge to prevent stability and put tension to them, so that way when the bridge bent, they would try to pull it back into place. So with these beams, I hooked them in and to help with my warping and see if I could help counteract some of the twisting that occurred. Unfortunately, it didn't particularly work that well, but that's one of the main things I added to help try to add cross stability due to my lack of surface area that we saw earlier in my cross joints. Now, if I was to redo my joinery, I would have made 2 dramatic different changes. I would have double layered my lap joints so that there was more surface area for the wood to stick together, creating greater strength and doubling up the thickness of wood in many areas. I also would have left a little gap in the middle of my lap joints to stick my triangle into, and this would have created more surface area for the triangles to be able to distribute more weight evenly into the bridge. I also would have changed my cross pieces into eye joints. I just kind of magically erased a chunk of wood here so that way you can see what's going on. I would have ran 2 beams across with a cross piece in the middle. This would have provided much more strength and stability to my bridge, preventing the warping that we saw earlier. My main problem with this one is I didn't have the proper clamps to make it happen, so that's why I couldn't have these pieces like this or like that. Yeah. Conclusion. My bridge came down to a couple main points. Talk about difference with compression versus tension, and how it's ideal to have your bridge in as many tension points as possible to keep your bridge stretched apart, as wood has more fibers and its tensile strength is greater when it's being pulled compared to when it's pushed together and snapping due to the fibers being pushed in on each other and being cracking apart. The ideal of how you orientate your sticks when you're putting them on your bridge deck to give the most stability to support what they need to support, as in when instead of having them flat where they bend, instead of having them on their side where they will stay straight due to them having a greater amount of wood to support the force being applied onto it from underneath, as well as having the grain running this way with it supported instead of having the grain running this way where it's not providing any support. We also had problems with enjoinery, whereas it's more ideal to have more surface area within the wood so that way you have a greater place for the glue to stick the two pieces together, as well as creating more double layers of sticks to have more strength to support the wood, as well as holding the different pieces together and orientating them so that way you have the most amount of wood supporting the most amount of weight as possible. And then we got down to the dreaded parallelogramming, and how if your bridge doesn't support the wood properly, it ends up bending and cracking. So you'll end up causing stress on your joints, which will end up causing failure and causing your bridge to fail prematurely in points where you wouldn't expect it to, such as where mine failed, right here, just breaking off in one little chunk there, whereas the rest of the bridge, completely stable and completely fine. My trusses hold everything. Just one failure in my joining right here ended up causing me to hold a less weight, and it's all due to the parallelogramming creating a greater force on this. We also talked about different ways of trying to prevent parallelogramming, such as these cross pieces right here and here, to try to provide tension on the wood to pull it back into the place, but quite frankly just enough wasn't enough in this case. So that's the end of my bridge video, and I hope I get a good mark on it. Thanks, Baze.